Hello guys, in this video how to implement a queue using two stacks. So input is A, B, C, D, E, F for example. Output also should be A, B, C, D, E, F. That means the order in which you add elements. So retrieval also same. We need to use stack, need to implement a queue. For example, stack follows last in first out principle. In the sense, the order in which you add elements, removing elements will be in a reverse order. For example, let's take this. He inserted A and then B and then C. There will be two pointers. One is pointing to bottom of the stack, another one is top element. Whenever he adds an element, top will be incremented by one position. So keep on adding, top will be incremented. Whenever removes it, top will be decremented by one position. So usually it has two functions. One is push and pop. So he added elements A, B, C in this order. So while removing, while popping, so order will be like this. CB. Q means follows first in first out principle. Added elements like this. A, B, C added. And the order in which you added elements will be removed in that order only. It has two pointers, one is a head and a tail. So initially head and tail points to same location. Adds an element to the queue, tail will be incremented by one position. Right. It has add and remove elements. See, our job is to implement queue using two stacks. Logic is initially I am taking stack 1, stack 2 of a 0 size. Case 1 is keep on adding elements to stack and then finally is removing all the elements. Here so this is the bottom position, this is the top position. So he added A, B, C, D, F and he wants to remove it. If he removes element from the stack, it will be returned last element, that is the top position. So in that case we need to remove all the elements or pop all the elements from the stack one. So here bottom position is F and top position will be A. Right. Then in that case output will be A, B, C, D, E, F. This is the order you want. Q elements. Right. So in this case is keep on adding all the elements, finally is removing. Right. Case 2. Plus means adding. He added only 3 elements and then removed one element. In that case logic will differ. So we are adding to S1. S1 has A, B, C elements. This bottom element or last element and top element will be C. What we need to do is asking us to remove an element. In that case A should be removed. Right. But in stack top element is C. So we need to copy all the elements from stack 1 to stack 2. Now the order will be like this. Bottom position is C and top position will be A. Remove that element. We need to remove A because we are doing Q operations. So now S2 is empty. S1 is empty. S2 will become, it has elements C and B. So here bottom position is C, top element will be B. Now he is adding another element D. What we need to do? S2 is empty. We need to pop all the elements from S2, add it to S1. Right. Now S1 will have a B and C. Finally he is adding D. So that element will be added to S2. So here what he is doing? Here is ABCD he wants to add. He removed one element, 1x. That means A will be gone. Now BC will be there. And he added element D. Now sequence should be like this. Right? Let's see the program. Here is the class. I am declaring two stacks. One is S1 and S2. In the public constructor, I am initializing stack values S1 and S2. And I have two methods. One is add. We are passing element here. Okay. And here remove means we are not passing any character. We are just asking the data structure to remove element. That means Q we are doing. So first element will be removed from the Q. So that removed element will be returned. Right. And in the main class, creating an instance of an object and adding elements 1, 2, 3 and 5, 6. Just displaying that means removing all the elements from the queue. See, you will see add method. In the add method, we keep on adding elements to S1. First case, keep on adding elements to S1. Whenever it removes it, at that time we are removing from all the elements from the S1. The S1 size greater than 0. Popping all the elements from S1, adding it to S2 and returning S2 dot pop value. This is the first case. See, here I am adding add 1, 2, 3, 5 and 6. Program. The order in which you added the 5, 6. Internally what data structures use doesn't matter, but Q follows first in first one. This is here 1, 2, 3, 5, 6. 1, 2, 3, 5, 6 we got. Now you added some elements, we will remove it. I am calling a remove 3 times. That means 1, 2, 3 should be gone from the queue here. Let's run this. we called remove function 3 times. Let's call 2 times or 1 time. We removed 1 time, that means 1 will be gone. Now remaining elements 2 3 5 6. Here we are getting 2 3 5 6. That's how we implement a queue using 2 stacks. Case 2 is a different one. Case 1 is simple. Case 1 is simple, keep on adding and removing from stack 1, adding it to stack 2. Case 1. Case 2 is mix and match, adding, removing, adding and removing. In this case, we need to follow this logic.